Hello, everyone. It's nice to see all the folks here. Get to talk to a somewhat new crowd here in New York. I'm on the West Coast usually, so it's nice to get to a different spot and get to talk through things. So I wanted to talk, jump into this a little bit of kind of a story arc, less about who we are and what we do, but more on how you can survive these large scaling events and how you prepare for them. It's easy to over-prepare, it's easy to under-prepare. I think we got just right on something that came up for us this year, and CockroachDB was a central part of that for the success on our side. So a little bit about me to kick off. I'm one of the co-founders and CTO here at Noteable. We're spread out across the US. We're a fully remote company. We founded in 2020, and we really built an extensive data and security-oriented version of what would be a hosted Jupyter notebook type of platform. So we provide all the kind of modern enterprise features you want on top of really popular open source software and make sure we're compatible in both realms. Previously, I worked at Netflix before this on the big data team, where we got introduced to CockroachDB there, as well as became a core contributor in the Jupyter space in that time. So lots of work around different data systems and helping teams kind of understand how to solve data problems. So what Noteable kind of looks like, so you get some context about what we're going to talk about in a minute. We work with data any way you want, so we really try to bring together rich visualizations, interactive commenting, real-time updates, all those types of features you would want in kind of a collaborative space with other users in your platform, or even external users, and then try to provide the kind of integration space that allows people to both share that in a controlled way, but also manage their security and their data, as well as get insights quickly that they can share with other people in the company. So for example, this is just a screenshot from one of our public gallery notebooks, which has contribution from people outside our community engaging and pulling in like, hey, what about this or that, or how do I want to change something or move something in here. So that's kind of a high-level context, what we provide as a service, and really enabling data stories to be realized. I feel like you can't have a talk in 2023 without addressing the elephant in the room when you're talking about data, which comes up a lot, is how does AI and LLMs plug in, integrate? And this is something I'm bringing up specifically because we had a very early engagement in the OpenAI space when the first wave of plugins went out back in May. We were in the first set of about 10 or 20 of those that launched with the platform. And so when that popped up, we saw this huge step in people having this ease of access that really fit with our story arc as a company. So we were oriented around enabling people that would normally not have access to data systems or to how to contribute or collaborate with people who were experts in data systems. And LLMs fit really well in that story arc because you can use natural language to describe your problem. And in our case, we enabled that to be realized into a codification as well as documentation that's paired together, which really brings a lot of people closer to the same set of problems, the same understanding, with a new interface for them to breach it. And so in this plugin that we launched, we traditionally were more focused on enterprise sales with kind of a multi-tenant platform. People get used to have a free tier to sort of play with our platform, understand what they were doing. And then instantly we saw 100x increased traffic on a rather heavy per user cost basis system. If you're not familiar with what a user would do in our system, when they are interacting with Noteable, at first they might be interacting with just your traditional SaaS software, request to update, a document or something like that. But as soon as they start running code, we're giving them dedicated hardware compute resources. And for most people, that's the free tier, is free hardware. So if you have a 100x increase, you now have at least 100x more kernels running. You have 100x more outputs being generated. In our case, it was even worse than that because the plugin was enabling people to use features that people got to typically later in the life cycle of interaction. And so you're asking questions, it's continually generating these very write-heavy instances on our platform. And before Noteable, I don't think I ever worked at a place where you had a 10x growth over a period of less than 3 months and something major didn't fall over and crash and burn. So when we started seeing this upward spike on our multi-tenant cluster, I was a bit of a panic of, okay, let's buckle down and make sure this is going to work. In the case here, we chose a particular set of technologies anticipating a growth spurt at some point like this when an event happens. So we had some smaller ones where people would use Noteable to host a conference or something else. So we'd see a big spike on a particular usage pattern, like maybe a big group that's using GPUs a lot, so our GPU use would jump up, or a group using it for documentation coordination. And in our case, we were really like worried and struggling with the the app kind of growing in that phase, and this ChatGPT growth was really important. If it failed, we would start falling off that most popular list. And luckily, because of the technology choices we made, as well as the reactiveness we had to the scale, we were able to stay on the most popular list even to today. And that has helped continue to drive the traffic to our site and continue the growth of our product. And a lot of those technology choices really kind of failed down into a few priority things in the day in the life. But a lot of it was rooted in decisions we made 6, 12, even 24 months earlier. But in the moment, in the day of the life, how we respond to a scaling event where we're seeing a massive increased usage and even usage patterns that weren't quite familiar to us, we didn't have the app completely prepared. Well, one thing we did was we made sure we had a very good response playbook, and we exercised that very heavily the first few days for anything that looked out of the oddness. So we had set up a lot of alerts, but we didn't have quite enough of them, and we basically were sitting there all day with the Datadog dashboards on one half our screen and everything else on the other half for a few days, just trying to understand, is anything going wrong? Is anything happening with the load? And whenever we saw something abnormal, we kind of start coordinating. The other thing we really got into was getting same-day hotfixes out as soon as any bottleneck was discovered. So as fast as we could, we take some shortcuts. We definitely skipped doing some of our load testing, some of our other patterns, just to get hotfixes out for things we saw that were starting to scale into problems. And typically, those for us were index-related issues. So the database layer, we were paying really close attention to, because that's where typically applications get bottlenecked, because we could scale up everything else pretty idempotently. And in that case, oftentimes it was a route capability, something we were doing that didn't have an index, or we needed to add maybe a new attribute for the query aspect to scope down what it was doing. The other thing that enabled this is something we were looking for is we had a pretty rich integration test suite. And I can't emphasize enough, I think some talks earlier today, we're really talking about, that's a must-have first. If you don't have that, you can't do any of these other things on this list. You can't go and do a same-day hotfix with reliability. You might be able to do it once or twice, but if you're doing it for a week or two, you're going to fall over and cause a bigger crash if you don't have good confidence in what you're doing. The other thing that you really need integration tests for is to know that the overall system that you're responding, if you had to do a more major re-architecture of how the system works, you really, really want those in place to be able to respond quickly. And then load testing, we definitely ramped up our load testing. That was maybe after the first week or two. We scaled up, okay, what do we think we're going to have in 2 more weeks? And then we started running that. And then we got preemptive on fixing things. And then from there on, we basically didn't have any issues because we were able to see what our growth would be expected in 2 or 3 weeks out, fix the issue the week before, and safely kind of go through the full routine. And I think getting that kind of maturity around processes you've done and stepping them up was the most important thing, but then the technology underlying it allowed us to do that. So what technology choices did we do to actually support this? I would say it kind of came down to these 4 being the most important, maybe not in this order, but close to. So for us, very early, we picked CockroachDB. We picked it for probably 2 reasons. One was the fact that we could deploy this across different environments, both on-prem and off-prem, with the same configuration on our end. So we very early got our Helm charts configured so we could deploy this in any cluster. So we didn't have to worry about if we were adding new cloud capabilities in a new cloud or new region, or even on-prem capabilities, that we could deploy the DB of choice that we have without having to reconfigure things. The second reason Cockroach really came in was the multi-writer. We knew we weren't be at a scale where multi-region would be a concern for a while when we first started, but the multiple writers makes a huge difference when you hit these types of scaling events. Because here, when we actually, which I'll talk about in a minute for how that looked. And the second choice we can have was very early, we picked Kubernetes. Now, I wouldn't recommend, if for most startups, you start your company and you're in seed or Series A, probably want to consider whether you choose Kubernetes or not. Today, there's a lot more people familiar with it, so it's less of a risk than when we did that. We chose Kubernetes early because we're providing arbitrary compute to our users, which means we need to dramatically scale compute nodes up and down and have very controlled lifecycle management of those. So we needed that for that reason anyway, so we also chose it for our application layers and really doubled down on doing things the right way there so that we could respond to events and isolate concerns, including creating new node groups and things like that to isolate. And then Datadog, in the past, this would probably have been, Sentry plus one of the other kind of metric monitoring systems. But Datadog these days combines everything. It's a little pricey, but as I'll say in a minute, it's worth every penny, and you really want to have good visibility into your app. If you don't have good visibility into your app, Doesn't matter what else you do, you don't know what's wrong. You're just going to spend hours or days debugging something, especially when you have an outage. And so paying for having that ready ahead of time and having it integrated into your incident response book, so when you do have minor issues, you're falling into understanding what the metrics look like and finding where you have gaps. I'd say we spent maybe 12 months on that, finding all the gaps that we needed to fill in order to have a good understanding of every aspect of our application and making sure they were being tracked. And then FastAPI, if you're in the Python space, I would definitely choose this over Django or kind of any of the other options out there right now, both because now it's at a good maturity level, and two, it really provides the nice balance between ORM and a lightweight API server, and it has lots of good support and tooling, so definitely suggest that if you're in the Python space, which we are because our user base is primarily in that space. So CockroachDB, we were talking some about why choose Cockroach, and for us, we chose it early because we knew we would have both these really write-heavy operations. When we, for example, have a user using a notebook session, every output they're generating is creating write requests. And some patterns, if you are familiar with how notebook outputs work sometimes, people generate thousands of these as fast as they possibly can. And if you have a bunch of people following a demo notebook at a conference and they're all doing this at the same time, your writes are very sporadically high. So we wanted to be able to respond to the high write load when it happened, even though most of the time it wasn't necessary to have really high write throughput. And then time travel queries, super, super helpful. If you're not familiar with those, I definitely suggest looking them up, especially when you're starting to see things, you're seeing DB contention, you can't understand what it is. Almost certainly you have some sort of queries that are doing some wide reach in your database that really don't need to be perfect in time. If you move those out of the way, they unlock a lot of your other queries, and it's really helpful for doing it. This is a lot like if you're used to old system, like a read committed pattern. From this, we had this 100x scale. We had a really sublinear increase in cost of operations. I think, had to increase our node count on Cockroach by 1. But at the same time, we had to triple the count of all of our other services, basically. And the reason for this is because the write load stepped up, but really what we discovered is once we add the indexes we're missing, the load that we had before came down quite a bit, and then it kind of leveled out. So if we didn't have those indexes ahead of time and we were to scale the right number of nodes, maybe we would have more nodes added, but it was trivial. We just increased the number, and like, boom, no problem there. So we were much more concentrated on the app things we had to focus on where our expertise was and less on the database. I will say the one con with CockroachDB is when you're hiring people, it's almost Postgres. Which is good and bad, more good than bad, but it definitely means you have to get these engineers comfortable for a few weeks or months with the things that are slightly different. Once they do, they'll oftentimes understand the value prop and no problem, but when you're hiring new people in or trying to grow a team rapidly, I would suggest making it clear to them that there are differences and there's good reasons for those differences, but it's very close contractually, so if you're familiar with something of how it worked from an interface point of view, it's likely the same or very similar. Datadog, I'm gonna spend less time on this one, but for us, we chose Datadog because it combined a bunch of tools in one. We didn't have to pay for 5 different services. It's one big service. We put everything in. One thing I would say is you do have to spend a little bit of time just making sure you don't go over your quotas. It's really easy, especially when you're trying to log everything, understand what's going on in your app. Once you do, you might want to step back a little bit on some of the excess logging or have it in a mode you can kick on dynamically. The one con of it being expensive, I would still say over and over again, don't build this yourself. I've been on many teams that tried to build these things themselves, and 4 years later, they're still not where you would be if you just bought the tool. So if you're doing metric and log monitoring, buy the tool. It hurts, but it's going to hurt a lot less than if you try and build it yourself. And you'll probably do it wrong. Kubernetes, again, we had a very complex system with a lot of needs. So for us, the kind of interest in Kubernetes as an environment was key because we really needed to have this dynamic allocation of resources going up and down, especially around events or growth patterns like the one we just described. The other thing, too, is if you do commit into Kubernetes, or when you do, getting your DevOps team that's familiar with it and training them and learning them, they can be very flexible and very powerful. Like our DevOps team is 2x effective to what DevOps teams I felt I worked on in the past were, simply because this tooling gives you the flexibility to do things the best way, and best practices in DevOps have converged towards a lot of the patterns that Kubernetes has. And the ability for us to redeploy our service in another place and have different development environments to work in, really easy to maintain and manage. And they work identically even though they can be in completely different regions or with variations in setup. The con is you have to find expertise, which 3 years ago was a lot harder to find. Nowadays, I think it's a lot easier to find DevOps folks with the expertise in there. I recommend getting at least one person on the team that has at least passing familiarity before you adopt, if not expertise. And then FastAPI, our users mostly are in Python. If you're familiar with notebook space, most of our notebooks are in Python that people provide, though we have other languages supported as well. And we wanted to have our development as close to our users as possible to understand, and FastAPI really fit that, especially with SQL Alchemy combining. The reason why I also bring this one up in this slide at a CockroachDB conference is we were one of the first users using FastAPI plus SQL Alchemy on top of Cockroach. So we were kind of early on hitting into the Python interface, the SQL Alchemy. Nowadays, it's very mature. We haven't had any issues in 3 years that have been significant. More problems actually with our data connectors that we build to other things than to Cockroach. So it works quite well, and there's full async support now, which there wasn't when we first started. Async Python has come a long ways. I definitely recommend now at this point, it's definitely production ready. So what did we learn from our tech stack really is we get this huge scaling event and a wide new group of users that were all across the world, including a bunch in Japan, which I still haven't quite understood. You know, when we kind of took this, so I wanted to bring a little bit of the learnings that we had from our tech stack and what led us, what were good things and bad things we did to get to this point. One thing I say, if you're betting on growing fast, know that your underlying tech stack could handle it. Don't necessarily build it out of the box for, I want to have tens of thousands to hundreds of thousands of users able to run this right away. But know what steps you would need to take in order to get there. You know, a lot of times we talk about when we make decisions on the tech stack about doing two-way door decisions rather than one-way door decisions. Like knowing where you're going and being able to backtrack a little bit if you make a wrong decision is really powerful. But also, if you know your growth pattern is to get to that goal, make sure you like, okay, we'll have to swap out this part, but we know we can when we get there. Or we're going to take a shortcut, but we know it's a shortcut, and we expect that to be 6 months, and be really clear with yourself. And then development lifecycle is really critical as well. And I think some of the talks earlier did a really good job talking to this around it's a skill set you build around continuous delivery and continuous testing. It took us maybe, I would say, a year to a year and a half to go from 2-week sprint cycles that were kind of click, hit the release button, hope nothing happens, to now an engineer says, I'm done with the feature, I'm clicking release. And you know, no one's worried. And I think that's the thing that you both have to learn as a team, understanding the pieces that are involved and what's going on there, but also the technology that you're using and how to be familiar with it, and this kind of gradually ramping up of capability within your organization to facilitate that running successfully. And that means understanding these technology choices you made, as well as getting a life cycle with your team that is establishing a faster and faster pace of these things without making them feel like they're burning out. So definitely like gradually work on that. I would double down on that being a very good learning that helped us a lot. I talked about the one-way door decisions and two-way door decisions, but you know, the other thing, part of that, it's okay to make one-way door decisions, which are decisions that are very hard to back out of, if you know they're on things that you're going to win harder on. I think this is a hard thing to look at. You'll get asked for all these things that maybe are potentials, especially when you're early stage. And I would definitely recommend when you look at what of these decisions that I could make out of things I might do that are going to make us win harder. They're going to make the things that we're doing well succeed more and continue to compound. And there, it's definitely okay to make one-way door decisions as long as you're understanding you are making a step function in a direction that you're not going to probably back out of. And then the kind of last learning on this was if you build your app the right way, your database should be where your bottleneck ends up. So one thing you can think about when you're doing load testing or integration testing, if you're seeing failures that cause the app to start having massive issues, and they don't eventually bottle down to either a code piece that you're shipping that's buggy, or a database layer problem, you're probably need to think about making your layers above that more stateless. And then in the case of that when you really get to it, CockroachDB helps eliminate some of the really hard to implement problems you'll run into when you hit the scale. The multi-writer, multi-region gives you some doors to open up that typically, if you're running an RDS solution, even pre-Aurora or post-Aurora, you would run into a hard stop of, I have to refactor my entire schema, which is going to take 3 to 6 months. And here you can kind of skip past that, go a lot further before you need to think about doing those types of operations. So thanks. If you do want to try out our app, there's a free tier you can sign up and use. You get free compute. You can play around with all the features that are there. Do give it a try if you want, if you're interested in that side of things. And I hope that was helpful for all of you that are learning what to do next. Thanks.